Okay. So now I go in and I can replace it. Rope, which I'll call R, and will be R as a function of Z, equals now we have rope as a function of Z. And we're trying to minimize that, right? We're trying to minimize how much rope we're using, which means that when we minimize, we're going to solve for Z, which, hey, Z is how far we are away from things. This is a crazy function. I don't know how to find the derivative of it. So what I'm going to do is I'm going to use my calculator in order to first graph this and then graph the derivative of that guy. Aha, it's already graphed. So when I was going through this last night, this was the equation, although I did a few things differently. So let me restart and write this a little bit differently. It doesn't matter. It'll still come out to be the same. You have to do x squared instead of z squared, right? Because we're on a graph of xy, so you need to replace your z with x. And this is what it looks like. So this is our function. We can see that there is a minimum right here. We could also my window, I think, went right away to this. Your window probably doesn't, because I had to mess around with the zoom and figure it out when I first graphed this. So you can zoom standard and then zoom fit if you want, zoom out, try it out, see what happens. Notice that my scale goes only up to 330 here versus 600 here. So my X's are a little bit more stretched out than my Y's. I've got a lot of Y's going on, so it's a little bit more compressed on the Y and stretched out on the X. So it means I hit zoom fit, and zoom fit figured that out for me. If I wanted to then graph the derivative, so I do this and then X and then F1 of X, we can see that the derivative looks not very helpful. I'm going to zoom in to see if maybe that does help at all. Zoom into like where I think all of this situation is happening. It's a line, right? And that's what you're seeing here, is that it's a line because we were decreasing for a really long time and then we were increasing, and it looks fairly linear the further out you get. We know that in order to minimize this equation, we're taking that derivative and we're setting it equal to 0. So I want to find where that 0 is. Analyze graph, 0. Graph, make sure you press the derivative function because we want to know where the derivative is equal to 0. And there we go. We have the derivative equal to 0 at 16.3. 16.3. So z equals 16.3. Double check that this is the answer. It says how far from the base of the shorter post should the rope be anchored, and realize that z is 16.3. While it's not visually accurate in ways that, like, obviously this should be more like over here, right? This should be a bigger stretch. 16.3 will be most of 25, right? So this should have been over here. But that idea that z had to go with 13, right? Because of the Pythagorean theorem. This is the distance away from the taller post. So even though the dimensions that you created might not be accurate, the relationships that you create in a diagram are important because I paired Z with 13, which means that was not the correct, Z is not our answer. It's 25 minus Z. That is our answer. But if you remember earlier in the video, you'll notice that my graph looked a little bit different. My numbers were a little bit different. And the reason why they were a little bit different is because in my diagram that I did, the first time I did this, I made this Z and then this 25 minus Z. And then I just forgot about that and did the shorter dimension as Z because it had less space to write. And that was what happened, right? But it doesn't matter which way you did it. I'll still get the same answer. I just know that the distance away will be 25 minus 16.3. Well, 25 minus 16.3 is what? It is 8.7. And that is the distance from the shorter post that would optimize, in other words, minimize the length of rope that I am using in this situation. So asking yourselves all of these questions, do I understand it visually? What am I trying to optimize here? How can I make an equation for that? How can I eliminate extra variables? Are the questions you need to be asking yourself and not just me. Okay. What is the minimum length of rope necessary? So we need to find out, well, what is R when Z equals 16.3? So we're finding what is R of 16.3. 16.3 because that was what we got for Z, but just Z happens to be this dimension and not the dimension we were looking for. But still, 16.3 is what minimized our equation. Go ahead and solve for R of 16.3. Going back to our graph, since it's already graphed there for you, right? R of 16.3 is your original graph. So I'm going to trace 16.3. Oops. And it gives me 32. So the minimum length of rope that you would need in order to stabilize these two vertical posts would be 32 meters of rope. Versus if you moved that one or the other way, you would need more rope than 32 meters. All right, good job.